Hello, everyone. Welcome to another episode of the AI for Us podcast. I'm Imran Mirza, your host. As a reminder, I'm a junior in high school, and I made this podcast just to spread information about AI and talk about the future of AI with AI experts. And I have our guest over here, Ojan. Would you like to introduce yourself?
Hi everyone, my name is Ojan Arifi. I wouldn't say I'm an AI expert, but I've been in the data science and AI field for quite some time now, even pre ChatGTP days. So, I'm here to offer my time and hopefully information to get everyone interested more in AI and uh, just talk about the subject that it's kind of my profession now. So yeah, that's pretty much it.
Yeah, that sounds amazing. Just starting off, tell us a bit about your background. I mean, even I don't know too much. I know that right now you work at Adobe. I've seen a bit of your LinkedIn, but just tell us a bit about yourself and how you got into AI and what you're currently doing in AI.
Yeah, so got my undergrad degree from San Francisco State. I got it in electrical engineering with a computer science focus, or excuse me, computer engineering focus. Um, excuse me. And so I always had an interest in figuring out how computers work. And so that's what's made me interested in going and studying like electrical engineering and computer engineering. So I got my degree there. Had a fantastic group that we did our projects together on, doing computer vision projects, utilizing things called FPGAs, which are kind of like a programmable hardware. So yeah, had a lot of fun there, San Francisco State, and then I kind of didn't know too much what I was going to do in terms of the next steps of education. So I was working at the time, doing work similar to like what's now known as like data science or data analysis or data analytics. And so while I was working, I was trying to think, okay, what's the next step? And I know I heard about machine learning, and I went more into machine learning. Uh, Took some specializations online, and then I decided for my graduate degree to go into uh, to uh, considerable uh, considerable like how do I phrase this? I basically decided, okay, I want to spend my time learning about AI and like push the limits of it and see what we can do with it. Because I always had this like for mathematics, and even more so than I liked computer science. And that was due to the fact that my mom was a math teacher, and like I always liked math. I guess I went more towards her side of the family, and all my uncles are also engineers, and they would always talk about mathematical subjects. So I guess it was always kind of like in my DNA. And so I decided, okay, I'm just gonna, go all in on AI and take a shot. And so I got accepted into the University of Michigan in Ann Arbor, and so I attended for my graduate degree there, and I finished that. I think a couple of years ago, not more than a couple of years ago, and that's basically how I kind of got a little bit more interested in like research in AI, and I started reading research papers a lot more, constantly trying to keep up with AI, um, and so holistically, all that together, my background is basically electrical engineering, computer engineering, uh, mathematics, and ultimately like how to build AI models. So my interest is very vast, and I I don't regret it. Definitely not. I'm very happy of the choices I made, and it's been rewarding, and it's been a fun journey. It's been very fun. Um, it's a profession that uh, I I highly recommend. young people to go into. It's cost effective, right? So you just have a computer and you can get open source models. You can get data from the web, and you can just start training models and trying to you know make them do things that are interesting. So I don't want to talk too much about that, but hopefully, as but so that's pretty much my background, I guess. So I can keep talking for a long time about it, but I'll stop there.
I mean, yeah, that's amazing. I think especially going to UMich for your masters and everything, and just having that math background from your mom being a math teacher, and then also your general family being a lot of engineers over there. I think that's great. So I guess just kind of going one at a time at the various things you talked about. Can you tell us a bit about those computer vision projects you were doing in your undergrad? I think it was.
Yeah, so computer vision projects were a mix of like cybersecurity and computer vision. So we made an obfuscation algorithm where we would basically obfuscate digital components. So, like digital gates, we would have the obfuscation code in Python to obfuscate those. And we basically had that hooked up to the computer. So, that algorithm, excuse me, was downloaded into an FPGA. And there was an image that was a secret image essentially. And if you typed in the correct password, the obfuscation algorithm would essentially stop working and you would see the whole image. So it's just kind of like it's not the most exciting project, but it was fun because we were utilizing computer vision in a unique way that's typically not uh, used in that fashion. So that's kind of like I had a great team, but it wasn't really like a useful project, but it was fun to do. Um, Later on, when I was in UMake, we had a lot more fun projects because that's when I really got deep into AI um, and into the theory of AI, like artificial intelligence. So, what does that compose? It's typically machine learning, but it also includes things like robotics and cameras and mm, data. So all this together essentially makes the field of AI, and it's the field of automation, right? So you want to utilize computational power and give the machine the ability to perceive things in the world that you can't do with just regular programming, like in just writing like a deterministic code, because that code cannot handle all the use cases of the real world variations that we have, right? So think of all the images that are possible in the world. Like that's an immense amount of different variations in pixels and in pixel positions, right? So the thing that like really amazes me about AI still is that we can give it an image and it could like describe textually what's in that image, and it can describe features and even what's happening. To me, that's just like so amazing that we can do that. Um, I'll tell you a story. So when I was a kid, um, this shouldn't digress too much, but it's kind of a motivation of why I think I went in this
Yeah.
path. Um, when I was like a young child, I was like 5, 6 years old. I would watch like Saturday morning cartoons, and this was back in the day when you didn't have like YouTube, so we were watching cable television, and so we couldn't pick the programming. So I was channel surfing, and I fell in love with a series. I think it was like a Batman series. Um, yeah, and it had to. Yeah, and I had at that time a toy computer that I really liked. So my father had purchased that for me, and I was always on there, like doing kind of like rudimentary programs. And so how that relates to Batman is that Batman has like a bat computer, I think is what he calls it, in his like little cave, and his computer could talk to him, right? So he would like speech talk to the computer, and the computer would talk. And I was always like, oh man, I wish my computer can talk to me. I thought that would be so cool if a computer can talk to you. And like not only could it talk, but it would like analyze images, right? So analyze like a criminal database, right? Because Batman's a superhero and he wants to go out there and catch all the bad guys. So like he would feed it an image, and they would like geolocate where that guy is possibly. It's a cartoon and not too technical, but for me I was just like, wow, mind blown. That's so cool um, that he can do that. And so that was another motivation for me, actually, looking back at it, uh, of why I liked computers and technology, and was just so interested in his computer, because basically that's artificial intelligence right there. A machine that's kind of mimicking humans, mimicking a human voice, mimicking human sight, right? So perception, which is for me what AI is mostly about, like perception and automation and robotics and all agentic design and all this. So that's kind of like, looking back, I always think, oh, I think that's where my interest started, was with that cartoon show at a young age. Yeah.
Yeah, I mean that's a really good backstory. I think it's very nice to, or it's kind of funny, not in a bad way, but it's very funny to think that a Batman TV show spiraled into your entire career now being into AI. I think that's a really nice story. I actually like it a lot.
Yeah, I mean, it's I guess partially true. So it is true. Like looking back at it, like yeah, I did. That was my favorite TV show at the time, and there's like on AI related things that I liked about that show. It was a show that essentially, I think it was done on black paper. So the cartoonists and all that were drawing on black paper, and so it had this specific kind of vibe to it, I guess, for lack of a better word. And so I don't know, I was just like visually appealing as well. But bas- basically, I really liked his Batcave because I thought it was so cool. He had all this technology, and that Bat computer would automate all his tasks and stuff. And uh, when I actually my father noticed that I liked the show so much that he went and like bought me a small like replica of the Bat Cave or something. It was pretty small, not too big, and it had this computer there. And I was always like, a big fan of that computer. And I would even like take markers and like write on the computer screen. It's a tiny, like, it's not a real computer screen. It was plastic, but I'd use my imagination. I would use different colors, and I would like put things on there and like draw pictures. So yeah, yeah. Again, looking back at it, these are the experiences that shape us. At a young age, right? So,
Yeah.
and I was about, I think, first grade or something, second grade, for kindergarten maybe. I don't exactly remember when. Yeah, but and also I'd mentioned earlier I had a computer. I think it was called like a WizKid something, like a WizKid 3000, and like it had programs, and you can kind of like it had games, and you can actually build your own programs with it as well, like very simple programs. I always had this like of computers and the AI because of that show, and yeah.
Yeah, I mean, I think it's also really kind of cool to see that all these sort of futuristic technologies you would see in shows like decades ago, it's kind of being we're able to make them in real life now, and it's because of AI. So I think it's also kind of a testament to what AI has been able to do for our society.
Yeah, yeah, yeah. It's changing society in ways that's going to be good. That's going to be good, but it also can be somewhat dangerous. With all these deep fakes and these scams. Um, So it's with every technology there's good and bad, right? So there's things we have to be careful about. We have to protect ourselves, our elders, who might fall for these scams. So there's always a market for things. So new technology brings uh, beneficial markets, but it also can bring up issues. And then another market is, I mean, not another market, but yeah, well, basically another market is created for handling those issues. And we have like our own hands are building something that is causing a problem, and then we have to kind of use these same hands to try to like mitigate that issue or solve that problem. And you know and that's kind of the story of, I guess, humans experiences with technology, right? Yeah, it's always it's neutral, right? So technology is neutral. You can use it for good, you can use it for not so good. um, yeah, and yeah, I mean, AI is pretty powerful. I don't know if you want me to get into the technical
You can
details
get into it.
about some of my experiences, but if that's something we can talk about, I'm definitely ready for that. So
Yeah, I guess it is definitely true. I also agree. I think AI is basically just a tool in the end, and you can use it for good or for bad. It really just depends on what you do with it. But going back to sort of not really going back, but kind of adding on to like you were talking about your childhood and what inspired you to get into AI. I kind of want to know like what you did in your high school years. Like that's kind of the age range of our target audience. So I kind of want to know what you did there to kind of prepare yourself for the future, for university, for your job in AI, and sort of what sort of advice you would give to our audience on what they could do to also prepare themselves.
yeah, believe it or not, I actually wasn't interested in technical things in high school. So my taste had changed a little bit when I was in high school, and that can be for many reasons. I was maybe interested in other things and other people rather than computers. But well, let me ask you a question. What do you think I was interested in, if you were to guess?
Can I ask if it was like a STEM field or not?
Yeah, yeah, it wasn't a
It
STEM
wasn't
field,
a
no.
STEM field. Was it like
Yeah.
animation or art?
Art, yeah, yeah. If you want to get particular, it was a particular, I guess, form of art.
Mm, I can't
Yeah.
really.
So
I don't really know any particular forms. I just kind of know art as a whole. I've never really been an artist.
yeah. Well, yeah. I mean, actually, it's somewhat still related, to, I guess, to technology. But I was really interested in like multimedia
Oh,
production.
multi. I think I've heard of that.
So I was interested in like audio production. And so when I actually got out of high school, because we didn't have like audio production in our school, our only electives was like a mechanic shop and um, I don't know, there was something else I forgot. But anyway, so we didn't have like an audio production at our high school that was like big. Like there was AV clubs, but I didn't really, like some of that crowd, and I decided not to do that. I did it mostly at home, but when I got to college, I had some friends that we were interested in doing like, AV related things. So um, even like a audio video basically is still related to AI in some ways because we're generating all this audio and video, but it wasn't really, I was doing it for more like multimedia and some aspects of art, so like music production for specific like themes of things, like how do you match the music to invoke a certain like emotional response in like your videos, whatever that might be. So, I was actually very much interested in the art aspect of things, and that kind of led me, I guess, to Adobe in a way,
Oh, that is true. Yeah.
because we do a lot of multimedia there. Yeah. So, So actually, wait, I wasn't into STEM, but later on, I started getting back interested into STEM again, and because a lot of like the audio production that I specifically focused on, like a lot of those sound waves are like mathematical functions. In a sense, you can kind of like sine waves and like a sawtooth waves, and like these things were always very interesting to me. I was always thinking, how do they like make this stuff? Like this is really cool how they can make these sounds, and some of the sounds are annoying, but some of them you can alter them, and it sounds kind of musical. So it always was interesting to me, and so I started going more into STEM in college actually. So I first came in with a interested in multimedia and like audio production. Then I shifted more back to STEM because I was always kind of inquisitive, and I hadn't focused too much on like science. And I wasn't a big fan of like chemistry, and like physics was more cool, but like chemistry, we had to take chemistry classes in college because at that time I decided, okay, let's go more towards the STEM route because I'm not a great artist. So I decided to do that, and yeah, so basically went towards uh, yeah, engineering then, right? So um, and then settled on electrical. Yeah, so my life, it seemed like a lot of things were, looking back, it was very much uh, it made a lot of sense of why I ended up where I am. So I'm thankful for that, and you got to enjoy the ride. So I did enjoy it. So
Yeah,
yeah.
that's good. That's good. I think there's probably some people out there who are also like having different interests right now, and maybe they'll go into STEM, or even vice versa. Some people who are into STEM but then realize they like something else later and have other passions. So I think it is kind of good to know that
Mhm.
you shouldn't force yourself to go into a field just because someone pressures you to go into it, or like you feel the societal pressure. I think in the end, if you really feel like something pulling towards you, or you feel a passion for something, I think it's worth at least going into there and just trying to figure something out, or just trying to play around a bit.
Exactly, exactly. You gotta kind of. I had a friend. He always told me, just do what you. Because sometimes I was worried about money. So when I was first doing the audio production stuff, I always thought to myself, I'm not super talented. I'm not well connected. Where's the money gonna come from? One of my friends told me, he was actually considerably older than me, but he was still a friend. And he said to me, and I don't know why I still remember this, but he really meant it when he said it. He's like, do what you love and the money will come. And that still resonates with me today, even after all these years. So that's, that's my recommendation, passing on his recommendation. Do what you love and enjoy, and the money will come. And just, I guess there's more to it than that, but that's probably part of it.
Yeah,
Yeah.
sure.
Uh,
All right, so I guess kind of focusing on AI now. What like experiences did you have since you got into STEM mostly in college? Like, what did you do to kind of get to where you are today? So you talked about, I think, like some online
mhm.
courses or certificates that you got. So what advice would you have for people right now just to get into AI?
Yeah, I mean, like, there's multiple different paths. So it depends. Like, do you want to, as a person, you have to make the decision. Do I want to be like a person that specifically goes towards research and like cutting edge AI? And like, do you like the fundamental like software architectures for AI and the modeling architectures? Or are you more like an implementation person who wants to kind of just get in there and build something and have it be out there and sell it or make your own business? So there's this kind of striking a balance. Do you want to be more towards research? Do you want to be more towards business applications, or maybe somewhere in the middle? You find your niche, doing maybe both. Um, so with artificial intelligence, I keep up with the research. I will make a point that a lot of the really great research that's architectural, so the model architecture, like the theory of how it's supposed to work, and how, like, neural networks essentially make up what is the transformer architecture, or how they make up the diffusion model architecture. um, Basically, diffusion is for image processing mostly, and transformers is for the text processing, right? So these um, you have to, most of the great research that I see is coming out of like China now, and like, companies like DeepSeek, um, ByteDance, Tencent, Alibaba. They're doing a great job, like in terms of AI research. It's really impressive. Um, so I kind of keep up with a lot of their channels, like YouTube or social media. I haven't joined WeChat or anything yet, but I might have to join WeChat or some other kind of Chinese, channels that can translate into English, to see what their true cutting edge is, um, in their language. But yeah, I'm really impressed by what they do, and their papers are a lot of them are in English, so anyone can go out there and read it, and and see what they're doing. So they this what's known now as reasoning models, uh, that came through DeepSeek, and it's work on what's known as reinforcement learning. So they use something called reinforcement learning in a unique way to train LLMs to essentially have a thought process or a reasoning process. Uh, so uh, an AI model, for example, like what's known as a transformer model, a lot of that, how it's able basically how excuse me it basically how it's able to generate text is by looking at internet text and then learning, okay, um, if I have this text, if I like finish the text and the last word remains, what's the probability that that last word is going to be like a certain word, right? And this is called like next token prediction. That's kind of how AI works. Excuse me, the models
Oh,
work. Yeah, so it's next token prediction, and these models do what's known as interpolation. So they are trained on a whole what's known as a corpus of data, and which means like a whole bunch of like text data. And there's different ways to train them, but typically they're trained by guessing what's going to come next, or guessing what's going to specific words in a paragraph that are like masked, masked, masked. So those masked text or like words, the AI model essentially will guess what that word is supposed to be. And if it's been trained on a lot of data correctly, it will do a really good job of guessing what is that word is supposed to be. And th- and we need this, and we need probability for this, because there's no exact perfect deterministic solution, right? So with there's variation in language that uh, you account for, but there's some things that are coherent and there's some things that are incoherent. So you have to train the model on enough data so that it can generate coherent sentences and paragraphs and essays even, um, and so it can become useful for us. And so that's just so basically that first part is called pre-training. That's when the model essentially learns how to think. Excuse me, not think. Learn how to, you know, display coherent, semantically correct text. And after pre-training, um, you have like what's known as post-training, where you can kind of have it become an expert in a specific subject, right? That's where you need to kind of fine tune, or for it to do tasks, for example, to have certain specific information, or to play a certain role, right? So as a chatbot for some bank, that chatbot has a certain role, like a certain personality. It's supposed to do some things, it's not supposed to do other things. And so what you have is a way to put that AI model into its role using like post training. And in the middle of that, there's a way called like instruction training or instruction fine tuning, where essentially it knows how to answer like questions. For example, if you give it a specific input, it's supposed to have like a more structured output. And this is where you get, like things like Chat GTP and all that Claude. So these are like essentially like AI chatbots. You talk to them and they can give you a response. So that's kind of like the first phase of AI with like Chat GTP. Then the another phase, or the second phase, is that it was able to utilize tools and reason, right? So you can, tell, I don't know, ChatGTP or any other thing that you're using, Claude, search the web to find me this information, and like download this, like the first five PDFs. So that's the model essentially has to do like tool calling. It has to call maybe an API, a web API, to connect to the internet, and like a search API maybe, and then it has a another API or another external tool that it has to call after that. So these are all like in steps, and that third tool that you call maybe downloads all those PDFs, or downloads those PDFs. So yeah, that's kind of like more the agentic AI, that second phase. So these are like, what everyone talks about when they talk about agents, is the AI that can interact with its environment and knows how to interact with its environment, and then that's really useful for automation, because now you can delegate tasks to it, and it will do those tasks, and it can do them pretty well. Yeah, so that's kind of like the second phase. Third phase, I don't know, maybe the future. Maybe we're not there yet.
Yeah, I mean,
So
that was still like a great rundown of basically how LLMs have been working for the past few years. So I mean, like just starting with the sort of encoder, decoder, and transformer architecture, and then going to agentic AI and agentic programming. I know, especially now, agents is kind of like a key word. Like everyone has been throwing it around. Especially, I think, like last year in 2024. I think maybe it's like died down a bit, but at the same time, it's still very popular. So I think that was definitely very informative
yeah,
for our viewers. So thank you.
yeah. It's yeah. I mean, something that I really wanted to actually talk about, also is, if I had to give like advice, especially because I have experience doing research. So I'm a machine learning engineer at Adobe, but I also do some applied research work as well, which is more like kind of like PhD level. Um, so I do read papers and like I implement things that I read, and I do make adjustments sometimes, or to the point that I might be able to write my own paper. I actually have written two papers, but I didn't publish them because I they became a learning experience for me. So I decided not to publish them uh, at that time, and I actually learned that what I was reading about or what I was trying was actually not the best way to do something, and that other things were better, or the how we have AI now is actually better. So when I was doing the research, I would always try to figure out, is there a better way to design like neural networks? Is there better architectures rather than just diffusion models or transformer models? Can we do better? And my my gut was that, okay, the market is really good at telling us like what works and what doesn't work. But I was always interested that maybe we can, something better can come up, or maybe I can figure it out. But my experience was that no, pretty much what we have now is really good, and it's really hard to go back to like the fundamentals and get things to like change, right? Because everyone has invested in like transformer models, and that architecture is there for like things like PyTorch and like using fine tuning models. We have like techniques for fine tuning like LoRa. We have like platforms that do all this. Like, a lot of money has been invested, and a lot of work is being done. So it's really hard to go back and like try to like from scratch like build something new, like fundamentally new. And it's really not super useful at this time to try to do that. Um, it's a little bit of history, like our neural networks are kind of based off of work that was done in like the 1950s, I believe. When they were first like developing computers, IBM, I think was part of it. Um, and I forgot the name of the person who actually came up with the perceptron, which is the idea of, you know, building basically is the foundations for a neural network, where essentially you have like mathematical functions, and your neuron activates when it reaches those functions reach a certain value or above, and that neuron activates and like it passes the information down to like another neuron. So like these ideas are like 70, 80 years old now, and a lot of why they aren't quickly implemented is because other aspects of technology and the ecosystem of it all hasn't really reached that level where they can like really test their knowledge and push the limits and see what they get. So it takes a long time some for things to fall into place. So like the work of a lot of people like from 70, 80 years ago has led to what we have now. So it's a very gradual process, and it takes time. um, and you can possibly maybe like try to uh, anticipate what's going to happen, but that's really challenging. A person who can do that will probably become very rich very quick. uh, so yeah, it's sometimes even if you have a good idea, if that surrounding ecosystem is not there, you might not see the fruits of your labor right away. If someone wants to go into research, just be careful that you might not see the fruits of your labor right away. It might be someone else who builds off of your paper, and then a technology comes in like 3 4 years that allows your research to like take the next step and lead to something really awesome. So yeah, research work is difficult work. It ends up in a lot of failure, probably like 99.99999% of the time. But it has to be done, right? People are interested in doing it because it's fun to actually kind of like ask a lot of questions and see, okay, what is needed next. What can we do? Hey, what if I try this? And you write a paper about it. With the internet nowadays and even AI, it can help you do research now, so which is really cool. So it makes a lot of the mundane, tedious, difficult things, much easier for us, and we can do things a lot faster. Um, and yeah, so it's great. So I recommend for the young people to really look into research and like enjoy it, and see what you can do, but just at the same time be careful about trying to reinvent the wheel, because some things are there for a reason, and the market forces won't allow much change. And the market has some point in time in the past decided that this is the best way, and they invested in that way, and now we've taken so many steps forward that going back and trying to reinvent the wheel just doesn't work anymore. So it's not a smart idea. So my recommendation overall would be, in a practical sense, like don't try to necessarily build a new neural network. because neural networks are fine, they work really well. Rather try to understand them and how they work and why they're used and why they're so powerful. Then after that, take another step. Okay, why is the transformer architecture really good for like text and like maintaining context throughout multiple steps of predicting like the next token, for example? Um, why is diffusion really good at image processing? Excuse me, not just image processing, but creating images, generating images, and generative AI, which also transformers are a part of. So yeah, I recommend just like, you might feel that maybe, okay, oh, it's going by so fast, but take the small steps and start from the beginning and learn why these ways work the best. And that would also help you if you want to do research. Um, I would say I would kind of be, and also you can research why certain like neural networks that have been, people have tried to make, why they failed. Like graphical neural networks are things that I wouldn't say necessarily have failed, but they're not. There's those, like there's graphical neural networks. Those ones are very niche and they're very specialized and they work only good in some cases. There's other kinds of neural networks like Bayesian neural networks, and these are different than like the neural networks that we use. But they have a lot of these have like high failure modes, and they have um, they work only in like specific applications, and they have like a lot of limitations. So like you have to kind of be careful about building things from scratch, from trying to reinvent the wheel. Um, yeah, and also even more like fundamental than that. Um, it's the question of like the purpose of like AI, right? Is to create something that kind of functions like a human, like a machine that functions like a human, a humanoid robot, a camera that can, take an image and explain to you what's in the image, and you can communicate with it and tell it, hey, generate something in this image for me, and it will understand in your natural language, right? So it understands this, what's known as unstructured data. Like images are unstructured data, uh, speech is unstructured data, text is unstructured data. So these, what we have basically is these powerful machines that are able to do this, but they have limitations in the sense that they are machines, right? They don't have like cognition in the way that we do, like in terms of a whole human experience, like a holistic human experience. And just because you can have multiple data sources, you can't really fuse that into some kind of cognition, or at least from my understanding is we can't at this time. And I don't really see any possible way that's going to happen. um, so there's going to be a lot of limitations, and you just kind of have to be realistic about what these what computers can truly do. um, you know don't expect to like throw a whole bunch of data at an AI model and expect it to give you all like the answers of everything, because it's, again, like human experience. We experience the world, we experience like the phenomenon of the world, like we can kind of like feel it and take it all in and have like an internal understanding of the world. But for a machine, that's very difficult. And many would argue it's just not truly possible. Uh, and I'm kind of that group because I haven't seen strong arguments to disprove that. Um, yeah, it's you know here's actually a research example. So I believe it was MIT and Harvard. They took a whole bunch of training data of like the solar system, and they trained a model, and that model was able to predict where things were supposed to be. If like, for example, if you mask the earth, and then okay, what is supposed to be here. It would give you something that essentially would well, I don't want to like mess this up, but I think it's basically was predicting very well at a high accuracy the things you would expect it to. But in the internal understanding of the model, how it was doing that was based off of like some correlated heuristic. So the neural model was learning something that was kind of weird, but only worked for this specific case. So if you try to generalize that out or like extrapolate it to for new scenarios, uh, those simulations would like fail miserably. Like it had all like the force equations all weird and all over the place. It, and that's just because like an AI model is like a statistical probabilistic model. It's really good at predictions and like understanding distributions, but it doesn't like perceive the world in the way that we do, right? So like causality is difficult for it. Like understanding symbols and to real world meanings, like grounding to reality, it's really hard for AI models to do that. And you have to kind of just deal with that, how you should use AI, and like if you want to research, where you should research, and even in practical senses, like how you should use it. Like you have to have like the right expectations of what it can do and how to model your data to get the best out of it. So yeah, that's on the business side and on the research side. These are uh, research does help business. So yeah, you find your niche basically.
Yeah, that makes sense. I've definitely heard that there's usually two tracks kind of for AI. You either go into research, and that's kind of more in the PhD side, and then also the industry side, which is more like going into a business or creating your own business, trying to get an internship out of college. And generally speaking, it's mostly just those two pathways. And so I guess we're going a bit over time here, but I just have two last questions kind of related to what you were just talking about. So one is just you're talking about how you need to know the fundamentals of AI, whether you're going into research or you're going into the industry. So I want you to give us some advice on how you can do that. So like if there's any specific online courses, certificates, or any specific books that you know of that could help high school students like me basically get into AI and prepare ourselves for college and the industry or research. And then also maybe you can talk. I know you were already talking about this, but talk about like AGI and ASI. Kind of talk about. Do you think that we're ever going to reach those levels? Like from what you said before, it kind of sounds like you
Mhm.
don't think that we can do that because inherently AI is just kind of like a statistical. It returns probabilities in the end. So in that case, I think you probably also agree that the AI probably won't be able to really replace humans in the sense. But I still want to know your opinion on sort of AGI and ASI.
Okay, yeah, I'll try my best to answer those. So for the first one, I kind of started off with the standard at the time, which was like the machine learning specialization from Stanford by Andrew. So he's kind of like the machine learning guy. I always liked his presentation, and I still kind of like keep up with what he's doing. Uh, so my I was introduced to him by a friend at the time many years ago. Okay, like this is the thing to watch, and that's a good starting point. And I think it's actually free, and he has an updated version of his original course that's from like 2013. I think a couple years ago he made an updated course, so it's like more graphics, better camera. So because the original video was like low quality and like it wasn't so great, but the content I believe is pretty much the same, and that's basically machine learning. Like it starts off with like what is a decision tree, what is uh, support vector machines. Um, what else we have? Neural networks. So he goes out over all of those, and that's a good place to start. Also, outside of that, probably looking at like, okay, what data interests you, and how can you make like AI mimic your data to like complete certain tasks. Um, like if you have uh, like if you have a whole bunch of data, like for example, like if you were doing recommendation system. Like you want to collect like data on the images that experience will entail, right? So train the model to recognize certain features of certain images that it's most likely to be exposed to, but also maybe like behavioral data from like user click rate or something like that, or how much time their cursor is on certain parts of the screen. And those are like things that an AI model can learn. Like it can learn those frequencies, those probabilities, and like mimic really well, um, and start to kind of, I guess, a little bit generalize, but within the training data. You know, so yeah. Again, like neural networks are kind of a black box. We don't exactly know what's going on. They're learning some kind of heuristic that is kind of hard for us to like fathom, because it's all these high dimensional correlations that is learning, that we can't really keep up with. So yeah, it's kind of, and another field is like explainable AI or explainability, which people try to figure out what the AI is kind of like thinking about, essentially,
Making
when
this
it's the
interpretability.
neural network, or what it's thinking about. And yeah, so your second question, like about AGI or like super intelligence, yeah, I kind of alluded to before. I'm more of a naysayer, because I don't really see it happening. I do see like a different kind of web for the future. So a web where you have like agents interacting with each other and doing a lot of things, like an agentic web, that together will be really impressive. I assume. I'm looking forward to it. If it can like share information very well, that would be very impressive. That would be very interesting to see, what it can do. And it might start to seem like super intelligence. But again, I don't see a way that these models truly understand the world, like what's known as a world model. It can kind of pretend to have a world model, but most AI has very poor understanding of the world, and that's like a limiting factor of it, as well as its inability to extrapolate beyond its training data. When we humans, we have like a strong world model, and we can extrapolate to like novel scenarios and like solve actual problems. But for AI, that's really like difficult with what we currently have. I guess the only I was actually recently thinking about this. The only way maybe is if you like use the human brain. So if you're like in the lab and you're trying to grow a brain and like trying to connect the human brain to like an AI model, I guess, or like some kind of like cybernetics or cyborgs or something. Uh, you might get something interesting, but even scientists, like, they have a hard time with cognition and like consciousness. Like, they don't really understand it from a biological point of view. As this is what I know so far, is they don't have any explanation for it, of how like the brain as a biological mechanism can like develop the mind, right? The consciousness. There's a divide there that might not be solved. Maybe it's not meant to be solved. I don't know. But maybe there's some things they can do with that, some with the human brain and connecting it. And I'm sure like Elon Musk is maybe interested in that with his Neuralink. Maybe he has some ideas. I mean, but again, then that's an issue of like ethics, right? Can you have a lab-grown brain integrate with a machine? Is that even possible? What are how the performance of it? And even like that, if you take it, if you want to hook up the brain to like a supercomputer, there's only so much the brain can do, right? And there's a lot of issues with it as well. So I'm more of a pessimist when it comes to like my interpretation of super intelligence, like an all excuse me, all intelligent sentient being, right? Sentient being, so it's like aware, like it can understand the world like more than we can, and like just figure everything out, easily. That's kind of a scary world, and a world that I probably wouldn't want to
Yep,
be in.
definitely.
And I just don't think it's really that possible. But I do, like I said before, think like an agentic web of what we currently have, connected, communicating, um, taking into context a lot of information, and processing, and other like technologies around perception, like around like how can you use maybe like advanced cameras to increase perception, or maybe some kind of robotics, or maybe a new kind of sensor comes out that might increase that. And so those I see more likely to happen. Yeah.
Yeah, that's interesting. I honestly agree with you. I don't think AGI or ASI. Maybe AGI can be like we can kind of I can see it being replicated, not really like a sentient AI, but I can see like technically right now you can say that ChatGPT and other models are like you can ask them a question about almost anything and get a relatively good answer. So I've seen some people say in that sense they are already sort of have general intelligence, but I'd still say that in terms of having an actual like sentient being from an AI. I don't really know if that's possible. I don't really believe in that either. So I definitely agree with you there.
Yeah. Yeah. Ultimately it's AI is artificial intelligence. It's not natural intelligence, right?
That's true.
Yeah, there's a lot of limitations. So you just got to make the most of it, make as much money as you can, I guess, and enjoy it.
Yeah.
Yeah.
Well, as
And
we approach the hour mark, do you have any final thoughts, any final advice?
uh, no, I think I pretty much covered it. Um, mm, yeah. I mean, you have to just, you know, define, I guess, your purpose in life. One of the things I typically do is I like to write a little bit and sometimes take a break from technology and just realize what it means to be human again. Basically, because I'm dealing with all like the software and like meetings, and then this technology, that technology, AI. So read this paper. Oh, this new paper came out. This and that. And it can be very overwhelming, for us as humans. So sometimes I like to take a break and go into nature, write, and just enjoy life without a little bit of technology, and enjoy the simple things in life, and appreciation, and like reflect, and contemplate, not just on technology but on other things. Maintain a balance is very good. It's a good job to maintain it. It's a good thing to maintain a balance, and not get obsessed with one thing. Yeah. So I have to admit, I got not so much obsessive, but I was always interested in wanting more about AI. Uh, trying to figure things out, but at the same time, I always kind of, okay, don't overdo it, and because it's ultimately it's just another tool, right? It's like a lot of other things, and there's way more important things in life than just like tool making, working with tools. That's just it's a part of it, but like there's knowledge of oneself is very important,
Definitely.
and you should. I recommend everyone take out time to really try to sit and understand themselves, and contemplate. And that for me, it's like a therapy. So I highly recommend that. That's probably my my last message for would be that.
Yeah,
Yeah.
I mean, that's great advice. I think we're all humans in the end, so it should be a priority,
Yeah.
not just to focus on worldly ideals, like, trying to make as much money as possible, or like, for example, just focusing on even your
Mhm.
passions, like if AI is your passion, programming is your passion. It's great to have that.
Mhm.
It's great to focus on that, but in the end, just kind of taking some time to self-actualize, kind of understand like why you're here and things like that. I think that's also
Exactly.
equally, if not even more important than focusing on, for example, your passions, like I said before.
Yeah. 100% agree.
Yeah, so I think that's about it. We're basically an hour on the dot, so I think that's actually kind of perfect. But yeah, I mean, thank you so much for coming. Thank you so much for giving your amazing thoughts and advice. Maybe I'll invite you again and we can have a second episode. But for now, that's about it. So I'll end the recording here. Thanks so much.
Thank you, Imran. Yeah, I appreciate it. Hopefully, yeah, next time, I'll try to think of some new material.
Definitely, definitely.
Awesome. Take care.